Hello, everyone. Um, Today I'm going to show you how to do a stress analysis on this I-beam that I created. So first and foremost, I want to show you how I created the web, uh, the I-beam. So first I created the sketch with the dimensions that I got from the Toolbox engineering Toolbox website. And I sketched it up in the sketch and then I extruded, made a pad um, of 178 inches long. So in order to do a stress analysis, we need to be in a static study workbench. So you can find it when you click on the compass, click on static study, or you can find it in my apps. I saved it in my favorite apps so I can easily access it. So when we get to the static study workbench, it will show us, it will brings up this assistant. We can bring a visibility manager, I'm sorry, the future manager that will show us the future that we have. Right now, it's in the red. That's because we don't have any material applied to it. So in order to apply material, we'll click on material, select material palette from the list here. And we can pick our favorite material. Let's pick plain carbon steel. Some reason lately I've been loving it. Click on this burger right here and click apply. Then it will ask us, basically, we need to go to our part and apply it to our part. Now we can see there's a material, plain carbon steel. So we go back to our simulation, our static study. Now we'll go down the list. So it asks us to pick a boundary. So let's clamp this face right here. So by clamping it, it's basically we're making it be fixed. It's not gonna move in any way um, or any under any load. So now we picked our boundary condition. Next we need to do is um, select our load. So we're gonna put a pressure right on top of a beam here. And the way we do it, we can either pick it from the command that we have here to apply a load, or we can click on the face and it will give us options of what we want to do. So we're gonna, if we hover over the pressure side, it'll give us more option to apply either force or remote torque or gravity or apply translation. So we're gonna apply some pressure and we're gonna select, let's say 10,000 newtons. See what it will do. The more you put, the more zeros you put, the more pressure you apply for it to it, it will take longer to process. So when you click on scenario in your future manager, which is located right here, it'll give you um, all the boundaries or conditions you apply to it to simulate. So now going down the list, it's time to run our simulation. We'll click on our simulation button here, and now it's processing. As we can see, the simulation is running. Hopefully no errors will occur this time. And it's running. So one more thing to note that Um, you don't have to use one clamp for multiple faces, but you can. It will let you. It will let you edit pressure points, pressure faces also. Ooh, simulation is complete. Yay. Now let's play it. So as you can see right here, there's a little plot window and it says bond misses stress. That means it shows a stress point um, where it's being made. So when we bend this part, the biggest area that's under stress is this right here on top where it's being bent. Now, if we'll choose displacement, this area is being colored because this is where part is being moved. This part, this area right here is moving from its original spot. There's other factors here that we can check. We can check to see how force is being reacted or vectors, reaction force vectors. Um, there is other ones, deformation. We can see how it's being deformed. We can see factors of safety, compression tension. Um, so if we want to edit our clamping or add more boundary or loads on it, we can either by just simply clicking on the for example our boundary condition, which is clamp that we have, and we can select another face to clamp. Let's do the opposite side. Here's our face, or we can just create a separate clamp, either or, whatever you like to do. I like to just add another one, another face to the original clamp that I have. So now since we changed our condition, we need to run a simulation again. We run a simulation, it does its thinking, calculating, um, and we can see our results. So of course the result's going to be different with two faces clamped instead of just one, because now we have two fixed faces that are not going to move. Okay, simulation complete. Let's see the results. Beautiful. That's our compression tension. As we can see in our compression tension is this is the areas that are under stress. It has a tension on these spots. So if we look at displacement, this is the area that's being displaced. That's the area that's being under tension. Von Moss's stress, von Misses stress, can see where the areas that are being under stress. So the part is being bent here. So of course we see some color, and the part is bent in the middle. So we can see some color in there too. So after we are happy with our results, we can play our animation too. If you scroll down in the commands, we can see a report. We can run a report. We can select the sections that we want to keep in our report. Click OK. And it will generate a report that we can give to engineer for review to see if the stress is acceptable or within the conditions that are allowable conditions or not. But 3DX does stress analysis does that report for you, so you don't have to do the calculations yourself, which is nice. So when we finish running our report, it gives us a book well, can't really say it's a book, but there is 11 pages here with all the stress analysis with different factors being applied to it. Um, that can be printed and given for analysis to the stress engineer. So that's how we run our report. Now we can save it, and the report is being also, our simulation is being saved in our tree, specification tree with the part. And that's how you do stress analysis um, on the part.